Hi guys, BuildZoid here, and today we're going to be doing a disassembly of this here GTX 680. It's a 4 gig FTW card. I picked it up on eBay. Um, I've wanted one of these for way too long. They've got a fun, like, first of all, I wanted a 4 gig GTX 680 because it's a relatively easy to cheese category on hardware bot for some benchmarks. So it's just like, I want a 4 gig. And then I also wanted a 4 gig 680 that didn't have a terrible PCB. And that's where it gets difficult because for GTX 680s, if you get anything with a reference GTX 680 PCB, it's terrible. So then, and then for the 4 gig cards, there's not that many options. So you can't like get I don't think you can get like a 680 Lightning 4 gig, but you can get a classified 4 gig, you can get an FTW 4 gig, and you can get a bunch of reference cards that are 4 gig as well. So I went for the FTW because the classified cards, unfortunately, are really popular for like flashing with Mac compatible BIOSes, and then they just end up ridiculously expensive because it's like, oh, but it's Apple compatible, therefore for your 2000, so for your, ridiculously overpriced pile of garbage, here's another ridiculously overpriced ancient GPU. So yeah, this right here, however, is not a Mac flashed card. But it is still, like, just because it's an FTW and it is a 4 gig, it is, like, I paid way too much for it. But, yeah. These are kind of difficult to find, also. So, yeah. Anyway, we will be tearing it down. I'm not really happy with the condition of this thing. Like, we can see, like, this screw right here, doesn't look very good. And it works, like it turns on, it installs drivers, it runs, but it is dusty and disgusting. So as we tear it down, like, well, I'm going to be cleaning this thing, that's for sure. Also, I gotta say, I always thought this was a sticker, like this texture right here. So I always thought that was a sticker. It's actually like textured, and I gotta say, this is one of my like out of all the heat sinks out there in terms of looks, I really like these. It's a blower, so I expect it to be absolutely worthless in terms of actually cooling anything, but it does look good, doesn't it? So, yeah, and the 680s don't pull that much power, right? As he says as he shoves 1.4 volts into it, which is actually the plan. I do plan to shove 1.4 volts into it, though I'll probably not do that on the stock cooler. Now, this is going to be a bit interesting to take apart, though, because I think we can pull the top like plastic cover first and then get to the fin stack without even pulling the base plate, because we do have a bunch of screws for the plastic. Yeah, that does look like it's going to be an option. So we're going to go for that because I'd like to well, pull off the fin stack without the base plate. Like I'm kind of wondering if maybe it would be possible to just cram a water block on this and keep the base plate. Then you could have like the tubing coming out through the fan hole as well, and then that would be kind of sick in terms of like you get to keep the aesthetic of the card without. Well, no, you'd still be compromising the cooling because there'd be nothing pushing air into the shroud. But anyway, let's put that away. It's just like it makes it easier if you pull the heat like the fin stack without the rest of the base plate coming off as well. Also, if I'm going to be cleaning it, I do need to disassemble it to the maximum disassembly state, right? Not just like pull off the heatsink and the base plate. I need to take the heatsink apart, so that I can clean it out and make it less disgusting. Also, because I do have a bunch of spare screws from other cards that I've bought on eBay, say to attempt to repair them, that kind of thing. I will be actually replacing all of the like ugly screws in the back plate. I'll probably find a match. Like, I'm not sure if I have. Actually, I might even have screws off of other EVGA cards that I can use. That'll be like they'll look the same because I don't want mismatched screws either. That screw looks kind of rusty. But whatever. I don't like dirty screws and mismatched screws. Just not okay. Like. Part of the thing for me with the older hardware is not just like it's fun to overclock, because a lot of the time it's cheaper, right? It doesn't have, like, it's cheaper, so you get more brave with it, that kind of thing. Um, Part of it's also that I do like kind of just restoring it. So, well, restoring it, because I'll probably end up adding capacitors to this thing, so I was right. The shroud does come off. This is actually pretty, like, thick plastic. I was expecting it to be a bit thinner. But it is disgusting. Like, that's for sure. It is very, very dusty. So, let's put that away and not, like, shake it too hard, because if you do that, then of course the dust will go everywhere. The base plate, yeah. Oh boy, that is disgusting. But it, like, at least the card doesn't smell like cigarettes, okay? Because cards that smell like cigarettes, you just can't wash that out of the plastics. Like, I had a card where, like, the shroud was just, like, obviously it belonged to the smoker. No matter how hard I washed the shroud, it smelled like cigarettes. So I was just like, okay, well, I guess we're not keeping the shroud anymore. Um, so this doesn't smell, so that's good. So this is just, like, it's disgusting and it looks awful, but it's just regular dust, not cigarette dust, which is, like, it's way worse as far as I'm concerned. It also sticks. Like, that's the other thing, is, like, it is very sticky and disgusting. So anyway, it looks like this is a vapor chamber cooler, because there's no heat pipes going through it that I can see, which is actually, I'm not sure if that's standard for GTX 680s, now that I think about it, because I do have a cooler that I ripped off of a different GTX 680, and that one had like heat pipes going through it. So that's actually kind of neat. This is also a very big fin stack, but again, it's a blower. I guess we might see some benefit, like, since I do run, like, test benches, there could be some benefit in running this without the back, like, the IO plate here. Because if you remove this, right, the main issue with any kind of cooling system is that you need to cram as much air through the fin stack as physically possible, as quickly as possible. You need to get as much volume of air through the fin stack as quickly as possible. So anything that restricts airflow, like, say, the backplate here, that obviously harms cooling. So if you're on a test bench that doesn't have, like, the slot bracing, right, that covers the center part, like that doesn't have the dividers for the individual PCIe slots, or if you just aren't using a proper brace for the card, right, that's always an option. You can just pull the back, like, we could just pull the plate, and that should improve thermals a bit. The other thing you can do is actually, like, cut into it to get it more open, but it's probably not that viable. I wonder also if you could, like, because I think that would be going unnecessarily far. Like, you could desolder the DVI ports, right? Like, just completely remove them. If you're only using the HDMI and DisplayPort, then you don't need these, and that would also improve thermals a bit. But that just seems really, like, even by my standards, that seems really unnecessary. Also, desoldering large connectors like that sucks. Like, it really, really sucks. Or maybe I'm just bad at it. And I've just realized that I do not want to flip this over on this mouse pad, because then I'll have a dusty mouse pad. I mean, it's already dusty, but then it'll be like this on it. So I'm just going to go grab something to put under it. Go. There. And we can continue the disassembly. Now, I do wonder, I expect there to be memory chips on the back, and we're going to pull the back plate for, well, actually, no. No. We are not going to do that way, because I'm pretty sure a lot of these coolers, the way they come apart is that the actual heatsink will be a separate, like, it'll be a separate piece from the base plate. Also, I should have this overhanging, yeah, because the thing is once you don't have the shroud on the card, right, the I/O bracket is actually taller than the rest of the card. So if you're undoing screws or something, you're actually going to be flexing the PCB against sort of the 2 points of contact, which, no, like, like, at the same time, cards are saggy, but I just like treating hardware way too nicely, and then shoving so much voltage into it that it might up and die anyway. So it's kind of that. But yeah, I do try to be sort of like, don't unnecessarily bend the PCB, don't, do those kinds of things to hardware. And then I shove like 1. Well, if I ever take... Actually, I might take this card Sub-Zero. There's not really much reason not to. Yeah, so I was right. The cooler's off now. So, yep, that's a vapor chamber right there. There's your little fill port. Well, fill port. That's the tube that they fill it with in the factory. Obviously, you wouldn't actually want to like you don't refill that. Okay, don't try to refill a vapor chamber. You're not gonna get very far with that. Anyway, so yeah, that's our vapor chamber. And there's our base plate. So actually, there might be water blocks that would fit on this. There might be. They probably aren't very like, because a lot of the bigger water blocks, they'd actually go into where the plate goes here. Like they'd collide with that. So yeah, probably trying to water cool it the way I was hoping to, not really an option. But whatever. So that's the vapor chamber, and yeah, the dust is just coming off everywhere now. Okay, so yeah, I should have brought more paper. Let's get the back plate and the base plate off. You know what? I have a bunch of spare magnets from some stuff I wanted to do once upon a time with magnets. So we are going to upgrade the screwdriver, because this thing's like, this screwdriver's magnetism sucks. So hopefully that makes it suck less. And nope, still sucks. I have a different screwdriver that's actually... Okay, no, not working. I guess maybe I could try more of the magnets at the same time. And actually, there, hang it off the desk. Well, actually, at this point, oh boy, is that... Oh man, that screw is... Yeah, I'm getting rid of that one. Where did he go? Oh, there. Yeah, that one's really, like, corroded. It looks rusty. Wonder how that happened. So, I won't be reusing that one. Actually, a lot of these don't look that great. Yeah, this one also doesn't... Well, it's nowhere near as bad as that first one, like that other one, but... A lot of these screws look like... And do I really want to reuse these? Because I could use nicer ones. Yeah. Well, the magnet's helping enough. Probably going to get rid of the sticker as well. I don't need a warranty on this thing, of course. like I would be ever able to RMA anything after I'm done with it, right? So... Okay, not that one. So I think that's the back plate at this point. Done. Yeah. There is thermal pads on this. Oh, yep. Yeah, it has the extra memory chips on the back. So that is... Oh, whoa. They have like a thermal pad for the back of the core. That's neat. That's actually really neat. I did not think they have that. That's cool. Yeah, that's a thing. That's a cool thing. Let's put that on top of the vapor chamber. So right now the base plate isn't going to come off because there's still a couple more screws left up here. But yeah, this is how the 4 gig 680s are made. You basically use the same exact memory chips as the 2 gig cards, except what they do is the memory chips on this card. So you basically have it's called the clamshell mode, where you basically have 2 chips in the same spot, but one on each side of the PCB, and they're reconfigured. So if you look at like DDR3, DDR4, there you'll have memory ranks, but for GDDR systems, they don't use ranks whatsoever. What they do, or at least GDDR5 and GDDR6, GDDR5X, all of these, the way they get the extra density is instead of trying to have multiple chips running in parallel, you just reconfigure each chip to go from, so normally a chip has a 32-bit wide interface to the core. These chips here will be configured to be 16 bits. And you don't actually have to buy any special bits. It's just like a configuration that, thing that is done, I think, with just a resistor on the PCB. So, yeah, that's kind of like you literally just get twice as many memory chips to get the extra density with GDDR memory systems. And then there's no inherent performance benefit to having twice as much VRAM, like say with DDR4, where if you have a dual rank memory configuration, you have slightly more performance just because it's dual rank. That doesn't apply to GDDR. You just kind of get you only get a performance benefit when you start running out of memory. Right, like that's the only, like, this literally just increases how much memory capacity there is. It doesn't inherently improve performance. It could, however, have some effect. In all probability, it makes memory overclocking worse, just because now you need to have, what is it, like 12 good memory chips instead of 6 good memory chips. Right? It doesn't add any extra load on the memory controller, though, because the memory controller still only has, the same number of actual connections. And so, yeah, still an interesting way that, an interesting sort of detail about GDDR5, in my opinion, that the way how the extra memory is handled. So, and there goes the base plate. And yeah, so the cool thing about this car, the FTW 680, is that it has a PCB that's basically a slightly cut down classified 680. And hopefully I'm not going to rip up the fan. Where's the knife? There's a knife. So, yeah, but the PCB on this is the... Oh, come on, they have it... Okay, well... That's not going to work. I'm going to try it differently. I hate these connectors. They freaking suck. Because they're designed to be plugged in and never to be unplugged. There. So, yeah. This right here is the main reason I wanted an FTW. So you get this kind of funky VRM layout to accommodate the blower fan. But also, this is actually a... So this, I think, yeah, that's going to be our memory voltage controller over there. This is vCore. And we can see we have 1, 2, 3, 4... I think there should be a fifth one somewhere. Wait, this is just an 8-phase? Still better than the reference. The reference card is a 4. So, wait, 1, 2, 3, 4, 5, 6, 7, 8. You can't have a 9-phase. What the hell? This has 3-phase memory power? There's no way this has 3-phase memory power. Like... Seriously? Oh my god, it does. Okay, so yeah, that looks a lot like 3-phase memory power. So we're gonna grab the multimeter, and I'm just gonna check that I'm right about that. Also, I realized that I set up the camera angle wrong, so bleh. So where is the multimeter? Oh, up there. Actually, no, that original camera angle would have worked just fine because you need to see the multimeter. I'm really, like, this is why most people don't try to, well, yeah, okay. There we go. So, I'm going to set this to resistance and 3-phase memory power, right? Because I originally thought this was a 10-phase. And... yeah, that's a 3-phase memory VRM. That's cool. So actually, like, here's the proof that those 3 inductors are connected. So this wire right here is the actual wire going through the inductor. How do I know that? That's just how they're constructed. So you basically have the... Like, actually, this is a... I've never cracked one of these open. I've cracked a bunch of other inductors open, but I do wonder what the coil inside one of these looks like, because That is actually kind of like the fact that you have this exposed part right here is just kind of like, that's a bit weird. But there are inductors out there where you literally just have a flat strip of wire when you need the really low inductance ratings, which these are, what are these? These are R30, so these are actually pretty high. Like, these are 300 nanohenries, so that's not that low. Still, anyway, so that is actually the wire just going through the inductor. And so we can measure from, and the inductor's output to the same power plane, so we can just measure from inductor to inductor, and we're going to see 0 ohms and 0 ohms. But if we try to measure to one on the V-core power plane, from the memory power plane, we're going to see the resistance of the memory plus the resistance of the core, because what's going to happen is we're going to be measuring through the memory to ground, from ground through the core, back to the V-core VRM. So if you measure from V-core to ground, I'll just use the I/O. That's always the most convenient place to get ground from. That's really high for a GTX 680 core. Actually, I'm not sure what a GTX 680 core is supposed to read, so 13 ohms? I was expecting a lot lower than that. I guess, like, 7970s are like 5 ohms. And this is, I think, a pretty, like, this is a smaller core, but 12 freaking ohms? Really? Yeah, it's 12 ohm core. Okay, well, that's a relatively high resistance for a GPU core, but it doesn't mean the GPU is broken. It just means, like, I don't really work with GTX 680s that frequently, so, yeah. Anyway, and then the memory is like 60 something ohms or something like that, right? Like that's actually, no, the memory should be like 50. Yeah. So it's like 65. So anything in that range is fine. Anyway, so yeah, we got the funky VRM layout, which 8-phase V-core, 3-phase memory power, which is like that, like the 8-phase V-core is already like that's a significant upgrade over a reference GTX 680. And I will do a full PCB analysis of this card later. I'm at 831. Yeah, we have 8318. So actually, this should work with the classified software, if I'm not mistaken. And then we have, I think these might be the same controllers that EVGA uses on the classified cards. So that was exactly what I was hoping for, is just like, this is a classified, but the thing is, on a GTX 680 classified, you'd have a monster V-core VRM. It'd be like, the card's like this tall, and basically, instead of just having, like, in total here, we have 3 plus 8, we have 11 phases here. But on the classified, you have 14-phase V-core, so the V-core VRM ends up like here, right? And then, because EVGA just uses the same 14-phase V-core VRM for several years now, so, or at least they did for a while. With the 1080 Ti Kingpin Edition, they finally used a different V-core VRM design. But from the GTX 580 classified all the way up until the, like, 980 Ti classified, the same, actually no, even the GTX 1080 classified, they kept using the same V-core VRM, and it's this monster 14 phase. And this thing basically is, and then behind that you have a 3-phase memory VRM that sits like in this area of the PCB. But with this card, you know, we have a cut down V-core. So it is just an 8-phase instead of the full 14 phases. But for a GTX 680 core, that should be, like, this should be plenty. You know, there's no harm in having a 14-phase, but the 14-phase was really designed more for powering things like the 580, the 780 Ti, the 980 Ti, right? It's very overkill for something like a 680. So the 8-phase version of that is plenty of power. Though I'm kind of surprised. Wait, are these dual drivers, or they are dual drivers? This might actually be a true 8-phase then. Because so these are 3598 for the we'll do that in the full PCB breakdown. But basically, yeah, it's an 8-phase. We have direct FETs. So, you know, those are some like these MOSFETs can handle a lot of current. And then the other thing that I like about this is, compared to the reference cards, you also get an upgraded output filtering. Again, the classified would have a more substantial output filter for the V-core VRM. But any amount of better than reference is a win in my book, right? Because getting a 4 gig classified, like those cards are like twice the price of this. Like I've not seen them at any price that's like even remotely reasonable. So I'm happy if instead of the 14 phase, I get an 8 phase and I don't have to spend twice as much. And also, I still, you still get the upgraded output filtering compared to a reference GTX 680. Like the reference GTX 680 VRM is just very bad. Like a lot of other reference Nvidia PCB designs, it's not great. So this is a really nice upgrade, and that's the main reason why I wanted an FTW. Is just like I wanted a 4 gig and I wanted one that had a PCB that doesn't suck. Though I was kind of hoping this was though I did think this was a 10 phase, but instead it's an 8+3. But I guess that might mean the memory overclocking could be better, maybe? Maybe? I don't know. Like, these are SK Hynix chips, so we're not on LPDA, right? Yeah. Wait, actually, these might be Samsung. I automatically assume that they're going to be SK Hynix, but they might be Samsung. Oh, that's a Samsung. Right? Yep, it's a Samsung. It's just upside down. That's why I'm having such a hard time reading it. So, just going to bring that up. Oh, nope. So, there, you can read it's Samsung. So, yeah. Anyway, that's it for the video. Now I need to go clean this thing because it is disgusting. And then I'm going to be rebuilding it and new thermal pads, which I'm going to be like, so pro tip for you if you're, rebuilding cards, check wait, is this looks like a separate part here. Is that just like, oh no, I guess that's just to prevent it from shorting out. Anyway, so yeah, tip with the thermal pads. To make sure that you don't get if you use the wrong size thermal pads, you can flex the PCB and break the BGA. Actually, you can break a lot of things. So, like, warping the PCB by using too thick thermal pads is actually how my previous GTX 680 2 gig ended up dying. So, straight up, like, make sure you have the right thickness thermal pads, because if you use the wrong thickness, you break things. Not impossible to repair, but difficult to repair. Very, very difficult to repair. Anyway, so the thing is, if you have even like a cheap pair of calipers, you can pull the thermal pad off and just use the calipers to check the thickness. And actually, I'll grab the calipers and check these right now. For the back plate, yeah. Because the thing is, sometimes you get thermal pads that, like, these look like 0.5 millimeters, but I'm really bad at estimating thermal pad thickness from my own experience with trying to do that in the past. Though, usually if you're off by like a fraction of a millimeter, it's not that big a deal. If you're off by an entire millimeter, that's when you start breaking things. So, let's get our thermal pads measured. So we're just gonna grab it, pull it up a bit, and then, yeah, that's like that. Technically, there is a 0.7 millimeter thermal pad thickness. That's like relatively standard, but nah, that's 0.5. Like the compressed part of it's 0.5. Right, like 0.6, well. I'm going to call that a 0.5. So that's a 0.5. These look thicker, just because these have to cover, like, the memory chips are obviously taller than a lot of the other board components, so, and these, like, direct FETs especially are rather low, but also 0.5. So these just look these just look puffed up, but, well, I wouldn't use a 1mm on that. Right? Like, it looks like these might be like 0.6 or 0.7, but I wouldn't use a 1mm on that. And then this right here, I'm going to assume, like, the other thing is like, once you check, like, a couple pads, they're probably all the same. Yeah, so that's another 0.6, which I'm going to just go with. Like, I'm just going to go with a 0.5mm thermal pad because I obviously don't have a 0.6. So, also, I don't think 0.6 is even really a thing. Though, you can kind of, like, there's nothing real. If you're a big hardware manufacturer, there's nothing really stopping you from going to a thermal pad manufacturer and saying, hey, we need 0.6mm thermal pads. Like, they'll just make them for you, right? Assuming you ask, like, if you order enough volume, you can kind of order pretty much anything, right? It stops being a problem. But, yeah, so these are all 0.5, and, well, actually, let's check the other ones. These I expect to be 1mm. Yeah, so these are 1mm, and even if I, like, push way down on it. So the thing is, that's, like, yeah, if you push way down on it, then it's going to compress. But these are 1mm. So, that's a thermal pad thickness. Actually, I think this one's also 1mm, but just in case. Wait, that what? Okay, no, I'll call that 1. Because issue is, like, let's pull more of it off. Really? Point? Like, it compresses down to 0.1. The thing is, I'm probably not going to run that back of core thermal pad anyway, just because, A, I don't think it does much in terms of cooling anything. B, yeah, this looks like it's a 1.5mm. B, I'm kind of thinking of maybe messing around with the capacitor configuration behind the core, and the thermal pad's obviously not gonna work with that. So I may as well just not bother with the back thermal pad. And now the thing I like to do well, basically with the thermal pad measurements is actually scratch them into whatever it is that the thermal pad is attached to, so that, because if you just Sharpie it on, then during the cleaning process it'll probably get washed off. So yeah, I'm going to be just scratching that into the backplate, and I'm not going to do that right here. You just take a, like, this is an aluminum backplate, that's an aluminum base plate. You just take something that's a harder material than aluminum, and you can scratch into it freely, right? We don't need to see that. So, yeah, that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. Thank you to the patrons for, of course, funding this purchase, because, well, like, I'm going to get a review sample of one of these in the year 2020, right? So yeah, big thanks to the patrons for funding everything I do here with AHOC. You will probably see this card on some live streams eventually. It's just like, well, I have a hardware hoarding problem, so it's nowhere near, like, the bigger issue is the concerning number of 7970s and 7990s I have. A second GTX 680 is not that big a deal, don't worry. But yeah, so I do have a Patreon where you can support me. There's a link down in the description below, which allows me to, pick up old hardware, old irrelevant hardware like this, and do a lot of the other stuff I do with AHOC. And then there's the AHOC Teespring store if you want to pick up any shirts, stickers, posters, the usual YouTuber merch. There's a link to that down in the description below as well. Both of those help out immensely with running the channel, so, I'd really appreciate it if you, well, use either of them, assuming that you actually like watching the content that I produce, right? Obviously, if you don't like watching my videos, then why would you help me, well, yeah, pay for me to produce them, right? It's kind of my views on it. Is just like that's people who support the channel on Patreon are basically paying for the videos to get produced. So yeah, that's it. Thanks for watching, and goodbye.